What if I told you that one of the most powerful parts of a bulldozer is also one of the simplest looking? A massive steel blade, sitting at the front of a machine, can push thousands of tons of earth, cut through solid ground, and reshape entire landscapes. But here's what nobody tells you. That blade is not just a piece of metal. It is a carefully engineered weapon of force, built from rare materials, extreme heat, and decades of mechanical innovation. Imagine standing beside a bulldozer blade inside a manufacturing factory. The steel walls around you shake as giant machines cut, heat, and shape metal that will eventually become strong enough to survive thousands of hours of punishment. Today, we are going inside the hidden world of bulldozer blade manufacturing to discover where these materials come from, how they are transformed, and why every millimeter matters. Most people never think about this, but a bulldozer blade begins its journey thousands of kilometers away from the construction site. Before it pushes dirt, rocks, or frozen ground, its story starts deep inside mines where iron ore, carbon, and other elements are extracted from the earth. And the first surprise is this: the strength of the final blade depends on decisions made long before the first piece of steel enters the factory. The journey usually begins with iron ore from some of the world's largest mining regions, including Australia, Brazil, and other mineral-rich areas. The ore contains iron compounds that must be processed before it can become industrial steel. A single bulldozer blade may require several tons of high-strength steel, and that steel begins as rocks containing only around 50 to 70% iron before refining removes unwanted materials. Think about this. The same iron extracted from the ground must survive enormous forces when it becomes a bulldozer blade. The ore travels through crushing machines, magnetic separators, and refining systems before reaching steel plants. The material can travel thousands of kilometers by rail and ship, creating a global supply chain where one missing link can delay an entire production line. Inside the steel mill, the transformation becomes extreme. Iron ore meets temperatures above 1,500 degrees Celsius, or about 2,700 degrees Fahrenheit, inside massive furnaces where chemistry changes the material completely. Carbon and other elements are carefully controlled because too much or too little can decide whether a blade survives years of impact or fails under pressure. But here's what nobody tells you. Making strong steel is not only about heat. Engineers carefully balance hardness, flexibility, and toughness because a bulldozer blade cannot simply be hard. If it becomes too brittle, one powerful impact with a buried rock could crack it. If it becomes too soft, the cutting edge would wear away within days. After refining, the steel becomes enormous slabs weighing several tons. These slabs move through factories using powerful cranes and automated systems. The journey from raw material to finished bulldozer blade has already consumed huge amounts of energy, and the environmental impact is something manufacturers are now trying to reduce through recycling, cleaner furnaces, and improved efficiency. The raw steel has finally arrived, but the real challenge is just beginning. A bulldozer blade must be cut, shaped, welded, reinforced, and tested before it ever touches the earth. And what happens next inside the factory is where ordinary steel transforms into a machine part capable of moving mountains. The first major step is cutting the steel into the exact shape of the blade. Huge CNC plasma cutters and laser systems slice through thick steel plates using temperatures that can exceed 20,000 degrees Celsius at the cutting point. The machines move with incredible precision, sometimes operating at speeds of several meters per minute while creating bright flashes of light and showers of sparks. After cutting, the flat steel pieces must become a curved and powerful blade. Giant hydraulic presses apply thousands of tons of force, slowly bending the metal into shape. The machine moves with controlled pressure, and the factory fills with the deep sound of hydraulics pushing against steel that weighs more than a family car. The next stage is welding, where multiple steel sections become one powerful structure. Skilled welders and robotic welding systems join the pieces using temperatures around 1,500 degrees Celsius, creating bright arcs of light that reflect across the factory floor. What happens next surprised even experienced engineers. The smallest welding mistake can create a weak point hidden inside the blade. After welding, the bulldozer blade enters a stage where strength is created at a microscopic level. The steel may look finished, but inside the metal structure, engineers are still controlling its future performance through heat treatment. The blade is heated, cooled, and hardened through carefully controlled cycles that can reach temperatures around 850 degrees Celsius to 950 degrees Celsius, changing the internal structure of the steel and preparing it for years of brutal work. The cooling process is just as important as the heating process. Engineers control the speed of cooling because rapid changes can increase hardness but also create internal stress. Water or special cooling systems may reduce the temperature quickly, sometimes dropping hundreds of degrees in minutes, creating a blade that can absorb massive impacts without losing its shape. But the blade is not complete yet. The cutting edge, the part that actually meets the ground, receives special attention because it faces the highest wear and impact. Hardened steel sections are attached with extreme precision, often with tolerances measured in millimeters, because even a small error can affect how smoothly a bulldozer moves through the earth. Now the blade moves into surface finishing and inspection. Large grinding machines remove rough edges while automated systems check the surface for cracks, uneven areas, or hidden defects. The sound changes from explosive welding and cutting to the smooth vibration of precision tools shaping every final detail. The final paint process does more than make the blade look impressive. Protective coatings defend the steel against moisture, rust, chemicals, and harsh outdoor conditions. The blade enters a massive painting chamber where automated spray systems cover every surface evenly, creating the familiar heavy equipment appearance recognized around the world. The modern bulldozer blade factory looks nothing like the factories of 50 years ago. Today, robots, computer-controlled machines, and artificial intelligence systems help engineers create components with incredible consistency. Laser scanners measure surfaces in seconds, detecting differences smaller than the thickness of a human hair. Quality control is where every blade must prove itself. Engineers use ultrasonic testing, laser measurement systems, and stress simulations to search for hidden problems inside the steel. A tiny crack invisible to the human eye can become a major failure after thousands of hours of pushing, scraping, and vibration. Before a blade reaches a real construction site, manufacturers recreate extreme working conditions. The blade may face impact tests, bending forces, and simulated years of heavy operation. Machines pull, press, and strike the steel because engineers want to discover weaknesses inside the factory, not in the middle of a mountain or mine. Most automated systems are incredibly accurate, but there is one moment where human experience still matters. A skilled engineer can sometimes notice a sound, vibration, or visual detail that a machine does not understand. Years of working with steel create an instinct that technology still tries to copy. And this is where it gets truly extraordinary. A bulldozer blade that appears simple from a distance is actually the result of mining, chemistry, robotics, engineering, and human craftsmanship working together. But the story becomes even bigger when we look beyond one factory and discover how this industry shapes the entire world. Every year, millions of heavy equipment machines operate around the world, supporting construction, mining, farming, and infrastructure projects. The global construction equipment industry is worth hundreds of billions of dollars, and bulldozers remain one of the most important machines in that network. Behind every road, dam, mine, and city expansion, there is a blade moving the earth. Did you know a modern bulldozer can push several tons of material in a single movement while operating in environments where temperatures, dust, and vibration would challenge most machines? Did you know some mining bulldozers use blades larger than a small house? And did you know the technology behind these blades continues to evolve with stronger alloys and smarter machines? Over the last 50 years, bulldozer blades have transformed from simple steel plates into highly engineered components designed with computer simulation and advanced materials. The future may bring lighter materials, electric-powered machines, autonomous operation, and AI systems that allow bulldozers to work with almost no human input. But one thing will remain the same: the blade must still be strong enough to move the world. After traveling from deep underground mines to advanced factories filled with robots and engineers, the bulldozer blade has completed an incredible journey. What started as raw rock from the earth became a precision-engineered tool capable of moving mountains, shaping cities, and transforming landscapes. The next time you see a bulldozer working, remember there is an entire world of science and human effort hidden behind that powerful piece of steel. Think about this: Every mark on a bulldozer blade tells a story. Every scratch represents thousands of tons of earth moved, every welded joint represents engineering precision, and every piece of steel represents a journey that crossed industries and continents. What looks like a simple machine part is actually a masterpiece created by nature, technology, and human imagination working together. And this is where the journey comes full circle. The earth provided the raw materials, factories provided the transformation, engineers provided the knowledge, and machines provided the power. But the most impressive part is not just the steel itself, it is the thousands of decisions, discoveries, and improvements that made this incredible machine possible. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.